Welcome back to Math 109 Plane Trigonometry. In this video, we're going to take a look at three Pythagorean identities that we have with the trig functions. So we're going to recall that by definition, r is equal to the square root of x squared plus y squared. Or if I square both sides, I get r squared is equal to x squared plus y squared. So you might recognize this as a form of the Pythagorean theorem, and that's going to be useful for us, which is why we call these Pythagorean identities. So, just for fun, let's go ahead and divide both sides of this equation by r squared. And I'm going to go ahead and separate that on the right-hand side of the equation. So I end up getting 1 is equal to x squared over r squared plus y squared over r squared. Well, I can rewrite that x squared over r squared. So I get 1 is equal to x over r squared plus y over r squared. Well, I know that x over r is the cosine, and I know that y over r is the sine. Well, that's not the way we're normally going to write that. What we're normally going to write that as is sine squared theta plus cosine squared theta is equal to 1. This is probably the most fundamental of the Pythagorean identities. It's the one that I actually have memorized after the years it's been since I've studied trigonometry. But let's have a little bit of fun with this equation and divide both sides of it by the cosine squared, or square the cosine of theta. So we end up with sine squared theta divided by cosine squared theta plus cosine squared theta over cosine squared theta is equal to 1 over cosine squared theta. So, obviously sine squared theta over cosine theta is the same thing as a matter of fact, I'll explicitly write that down. Sine theta over cosine theta squared. Cosine squared theta over cosine squared theta is just 1. And then I can say 1 over cosine of theta squared. So now we're going to use those reciprocal identities that we derived in the last section. So we can say tangent squared theta plus 1 is equal to secant squared theta. So that's if we divide the base Pythagorean identity by the cosine squared of theta. So now what's going to happen if I take that same identity cosine squared theta is equal to 1. And now I'm going to divide everything by the sine squared of theta. So again, sine squared theta over sine squared theta is just 1. Oops, I do not want an equal sign there. And then cosine squared theta over sine squared theta is the same thing as cosine theta over sine theta, whole thing squared. And then on the right hand side I can say 1 over the sine of theta squared. And then cosine theta over sine theta is the cotangent, so I get 1 plus cotangent squared of theta is equal to cosecant squared of theta. So these are the 3 Pythagorean identities. These are identities that I don't necessarily expect you to have memorized. I will give them to you on the exam. But it's a good idea to see where they're derived from, because it can be useful later in the course when we start deriving more identities. So that does it for Chapter 1 of our text. In Chapter 2, we're going to start talking about right triangles and working with them trigonometrically.